All right, so we're going to do multiplying and dividing rational expressions today. So first we're going to start with multiplying. Now multiplying and dividing are really the same thing. Dividing just has one itty bitty little tiny extra step, okay? So if you think back to when you were multiplying fractions, well, when multiplying rational expressions, you're using the same rules as multiplying fractions. So when you had to multiply like 3 over 2 times 2 over 4, you multiply the top, 3 times 2, which is 6. You multiply the bottom, 2 times 4, which is 8. And then you reduced it to 3 over 4. Now, we're actually going to reduce before we multiply, and you could have done that here. Like we could have canceled these 2's out and would have had 3 over 4. Okay? Which is what we're going to do because we're going to now have variables now when we're multiplying. Okay? So, there are some steps when multiplying rational expressions. Okay? So, steps for multiplying. First and foremost, factor everything. You want to factor everything. Okay, if it's factorable, factor it. Get it down to the bones. Okay, after you factor, you want to cancel out like terms on top and let's go over here. On top and bottom, just like we did with simplifying. Okay, and then last, you want to smush what you got left, and that is your answer. Excuse me. Okay, so 3 steps is all we got. Dividing is going to add. All right, so let's do a problem with the steps in the picture. Okay, all right, so we're going to do number 1 is going to be x squared plus 2x minus 8 all over x squared plus 4x plus 3 times 3x plus 3 over x minus 2. All right, so I need to factor everything. So the top is a trinomial. What multiplies to give me negative 8 and adds to give me 2. So that's going to be x plus 4 and x minus 2. Sorry. Had a brain for it there. Okay, and then the denominator is also the same thing. You got to factor it, and it's going to be x plus 3 and x plus 1. Okay, guys, you really need to know your factoring. If not, let me know and we can get some more videos going for you, okay? Now, this top one, it is not a trinomial, so we're going to look for a GCF. Well, they both have a 3 in common, so we're going to pull that 3 out, and it's left with x plus 1 all over x minus 2. Now you need to cancel out like factors on top and bottom. Well, x plus 1, x plus 1. And that looks like, x minus 2, x minus 2. All right, there we go. Smush what you have left, and we'll smush that 3 to that. So it'll be 3 times x plus 4 over x plus 3. Now, if you want to distribute that 3, you could write it as 3x plus 12 over x plus 3 also. Either one is an answer. Okay? All right. Let's do another one of multiplying. So it's the same as simplifying that we did yesterday, except I'm adding one more rational expression to it that you have to simplify. Okay? All right. Number 2. This is going to be x squared minus 9 over x squared plus 5x plus 6 times x plus 2 over 3x minus 9. All right, let's factor everything. X squared minus 9. Remember when I tell you it says x squared minus a perfect square? You are just doing the square root of that perfect square. Well, the square root of 9 is plus or minus 3. So it's going to be x plus 3, x minus 3. Denominator, and we'll factor it. And that's going to be x plus 1 and, nope, I'm just kidding. That's 2 and a 3. Times x plus 2, you can't factor, it's already down to the bones. This one is a binomial. It's got a GCF of a 3. I can pull a 3 out, and I'm left with x minus 3. Now we're going to cancel out those like factors. X minus 3, x minus 3, x plus 3, x plus 3, x plus 2, x plus 2. Now, great example, okay? See how there's nothing left on your numerator? In a rational expression, you gotta have a numerator, okay? Gotta have a numerator, especially if you got a denominator. Now, if you don't have a denominator, okay, But you got to have a numerator. So we're going to put a 1 there. If everything in the numerator cancels out, you put a 1. And then the only thing left is this 3. So this expression just reduced down to 1/3. Mind blown. All right, let's see here. Next one is going to be, so number 3 is going to be x squared plus 19x plus 84 all over 4x minus 4 times 2x minus 2 over x squared plus 9x plus 14. All right, so I got to factor the top. I need something that multiplies to give me 84 and adds to give me 19. Well, let's break down 84. I'm going to use my calculator. 84 is going to be, let's see, let's divide it by, it's going to be 4 times 21. All right, but 4 plus 21, that gives me 25. That's not 19, so that ain't it. Let's see, not divisible by 5. 6, let's see, it'll be 6 times, my calculator's down, hold on. It's going to be 14. Well, 6 and 14 gives you 20. We're close. Let's do 7. 84 divided by 7. That's 7 and 12. Well, 7 plus 12, that is 19. So there we go. That is what we call trial and error. Okay, that is what you're doing. That's what I'm doing in my head. Now, bigger numbers, we got to come to the side sometimes. So it's going to be x plus 7, x plus 12. Okay. The denominator is a binomial. What do they have in common? They have a 4. Let's pull it out. And it'll be x minus 1. Okay, when you're doing GCF, you're dividing by what you're pulling out. So 4x divided by 4 is x. 4 divided by 4 is 1. That's how I'm getting those, okay? All right, times another GCF. We're going to pull out that 2. Divided by, now I need something that multiplies to give me 14 and adds to give me 9. Well, that's 7 and 2. Now let's cancel out. X plus 7, x plus 7. X minus 1, x minus 1. Now, I want you to look at this 2 and this 4. Let's smush and look at it. So I'm going to smush everything on top, which is a 2x plus 12. Smush it on bottom, which is a 4x plus 2. If you were to look at 2 over 4 by itself, what can 2 over 4 reduce down to? 1/2, right? Well, then let's do 1/2. Okay? Or x plus 12 over 2 times x plus 2. Okay? So when you have numbers on the outside, I usually wait till the end, and I reduce them down once I've got them all together. That's what I do, okay? All right, we're going to do one more multiplying, and then we're going to go to division, okay? All right. So let's see. Let's go to, really dig in the blue. So this is number 4. We've got x squared plus x minus 6 over x minus 5 times x squared minus 25 over x squared plus 4x plus 3. Okay? All right. So we got to factor the top. What multiplies to give me negative 6 but adds to give me 1? Well, that's going to be x plus 3, x minus 2. Because 3 times negative 2 is 6. 3 plus negative 2 is positive 1. X minus 5 is done. It's to its bones. 25 is a perfect square. X plus 5, x minus 5. All over. This is going to be x plus 3, x plus 1. Cancel out. X plus 3, x plus 3. X minus 5, x minus 5. Smush what you got left, and I got left x minus 2 times x plus 5 all over x plus 1. And that is your final answer. Okay, now dividing. Dividing is literally the same thing except one extra step. Just one tiny little step, okay? So, steps for dividing. So the laptop died on me, but these are your steps for dividing, okay? You filter everything, you keep, change, flip, you cancel out factors, and then you smush what is left. So the only new guy here is going to be number 2, Okay, the keep, change, flip, which you guys should remember when you were dividing fractions. Like when I said to divide, like when I say divide 3 divided by 2/3. You keep the first one, change division and multiplication, flip the last fraction. Okay, and then you would have 9/8. Okay, that's what we're going to do. So we're just going to be doing irrational expressions. Okay, all right, so let's go ahead and do one. All right, so number 1 for dividing is going to be x, I don't know why I did that, x plus 2 over x plus 3 divided by x squared plus x minus 12 over x squared minus 9. So the first step is to factor everything. Well, this first fraction is already factored. Okay, I can factor this one. What multiplies to give me negative 12 and adds to give me 1? Well, that's going to be 4 and 3, and it's going to be a plus of 4 minus a 3. Perfect square. That's going to be x plus 3, x minus 3. Then we're going to cancel out our like term. No, first, before we cancel out, my bad. I was on the multiplying juju train. So you got to do keep, change, flip. We're going to keep the first one. Change division to multiplication. Flip the last one. Okay, so keep, change, flip. Now we're going to cancel out like stuff. I got an x plus 3, x plus 3, x minus 3, x minus 3. Smush what you have left, which is x plus 2 over x plus 4. And that's my answer. Okay, so it's the same thing we've been doing. We just added one extra step. Okay, all right. So let's do, so there's also another way you can write division, but it's really the same thing, okay? So don't let it freak you out, but you could see a division problem like this. Don't like that problem. Let's go, here we go, got one. All right, you see how it's got this divided by this? Well, that really just means what we've been doing. It's just written in a different way, okay? You can, I would actually come to the side and rewrite this guy, okay? All right, so we need to factor everything. This is a GCF factor. So what does 12 and 18 have in common? Well, they have a 6 in common. Now, anytime there's a negative out front, I pull that negative out, okay? So I'm going to pull out a negative 6, and when you pull out a negative, it changes the signs. So this is going to be 2x minus 3 all over x squared minus 25. That's a perfect square. So x plus 5, x minus 5, divided by 4 and 6 have a 2 in common, which would be 2x minus 3. What the bottom's going to be what multiplies to give me 10, negative 10 adds to give me negative 3. Well, that's going to be 2 and 5. Yep, 2 and 5. Okay. So we're going to say x plus 2 and x minus 5. All right. Now, before we do this, we got to do the keep, change, flip. So you keep the first fraction. Change the second one, like change that to multiplication, and then flip that second fraction. So the denominator becomes the numerator, and the numerator becomes the denominator. Now we're going to cancel out like terms. 2x minus 3, 2x minus 3. X minus 5, x minus 5. Smush what you got left. Negative 6 times x plus 2 over 2 times x plus 5. Now again, we have numbers. I reduced them down last. Negative 6 divided by 2 is negative 3. And that would be your answer. Okay? All right. Let's do another one. Do you see how if you don't, factoring is just so important. So guys, please let me know. Please let me know if we need some more help with factoring, okay? All right, number 3 is going to be 3x plus 12 over 2x plus 4 divided by x squared minus 16 over x plus 2. You got to factor. 3 and 12, they have a 3 in common, so I'm going to pull that 3 out. 2 and 4 have a 2 in common, so I'm going to pull that 2 out. X squared minus 16, perfect square alert. And then x plus 2. Then we do our keep, change, flip. All right. Cancel out your like terms. X plus 4, x plus 4. X plus 2, x plus 2. Smush what you got left. Now 3 and 2, you can't reduce that anymore. So that would be your final answer. Okay? Alright, so that is it for this video. Alright guys, I'm going to put multiple videos up for today to help you guys out. So let me know if you need anything else more than that. Okay?